My name is Paavo Ritala. I'm Professor of Strategy and Innovation from LUT University, and I'm happy to introduce Sabine Brunswicker. She joins us from Purdue University from the States, and she's Professor of Digital Innovation. And she's been doing a lot of research on digital platforms and different technologies and how they can help us to use the crowd and to provide us some solutions to different types of problems. And now we have a big problem, and I'm really excited to hear different types of initiatives and solutions that we can offer with the help of digital technology to resolve the COVID crisis. So Sabine, the floor is all yours, and about 20 minutes the presentation, and then we'll have time for Q&A. So everybody in the audience, if you have questions, please post them in the Q&A function in the bottom of your screen, and I will moderate the rest 5 to 10 minutes discussion when the time comes. Okay, please, Sabine, go ahead.
Thank you, Paavo, for this introduction. It's my pleasure to be here. And some of you might know I have European roots, but I'm here at Purdue. In case you don't know where Purdue is, that's somewhere in the Midwest, and it's known also for his program in aviation. If you know Neil Armstrong is one of the graduates of Purdue. It's my pleasure to contribute to this conference, and my title of the presentation that I'm going to give is about responding to the crisis with digital innovation, leveraging digital platforms, crowds, and AI. I'm a computational social scientist with strong, actually, roots in the world of innovation, social science, but computational social science means that I'm also spanning disciplinary boundaries with information systems and recent strong interest also in data science and artificial intelligence. And I'm really excited to be here at ISPIM to use some of those insights to share my view on how we can innovate during a crisis like COVID-19. What I'm going to do is I'm going to introduce digital innovation from my point of view, platform, crowds, and AI, give you some examples of digital innovation as a response to the crisis. What I'm then going to do is sharing some insights from prior research that highlight the challenges, but also the opportunities of digital innovation as a response to the crisis. I would like to conclude with also an invitation to participate an own effort that I'm driving here at my Research Center for Digital Innovation, a COVID-19 data science hack that might be important as we are now moving out of the lockdown and trying to understand the COVID implication in an economic and a social way. Well, long before we had the COVID-19 pandemic, digital innovation was around. And there are kind of 6 core technologies that were also highlighted in reports, consultancies were talking about it. We have the cloud. You don't need your hardware infrastructure. You can just now store data, analyze in cloud. Google Cloud, etc. may be familiar products you know about. We have IoT, connected everything, sensors that communicate with each other, where hardware is interacting. Mobile and social media allow people now people to interact and communicate in completely new ways. So digital technologies afford more distributed and open forms of organizing the design of new products and services. And platforms are out there that you all know that are successful, for example, Firefox plugins. We have mobile apps, all the value of mobile phones are now driven by the app developers. Salesforce, enterprise apps, Google Android, Facebook games. There are many, many more that you might know that are successful, for sure. There are also failures. Consultants project that the digital platform market has a value of more than 7 trillion in the future. And what's also important to keep in mind where this value comes from is because the way they are designed create new value by allowing producers using the platform's core functionalities that open the platform to producers. These are app developers, scientists, designers, whatever you can think of, in exchange of value for the users. From an economic point of view, that implies network effects, direct and indirect one, because the more apps you have on the platform, there's the more value also for the user. However, there's also a technical aspect. Some of you that might be familiar with the platform literature a little bit, there is also a lot of changes in terms of the interfaces between the different components. And we talk about open standards now, we talk about open source. For example, to actually be an app developer, you now have access to thousands of APIs, so-called program interfaces, SDKs, which are toolkits, libraries, etc., that you can use, and also a software programming language, Swift, to actually build the app that is then available for users on the platform. So it's not the platform itself that creates value that is the driver of innovation. It's actually all those producers, those thousands of individual crowd developers that create the value. Well, it's not just transforming software, it's also transforming science. For example, I've been working with NanoHub, which is one of the largest platforms in science and engineering, where scientists out of not just write papers, they also build simulation tools where other users on the platforms then can explore scientific principles and in the field of nanotechnology and science in completely new ways and simulate using the cloud-based infrastructure in the cloud. There are thousands of tool developers that also use interface, a Raptor toolkit, and have lots of development tools, libraries, etc., and then build the apps, and that is then accessible to others, to students, to other scientists that don't have the cloud infrastructure or these simulation environments that are needed. And it is also transforming, it has been transforming prior to the pandemic, the manufacturing sector. Here's an example that I like quite well. John Deere, they build tractors. Now they've started to build a platform around their tractors. They have a platform where you connect different data, different machines that you need on the farm, different systems, and this platform is also open to third-party developers so that you can implement or use a third-party software development to predict whether you need to water your plants, when you should actually go out there and take care of your crop. And this is just one of the examples, but if you have seen a recent report written by one of my colleagues for the World Economic Forum, there's MindSphere, there's ABB Ability, there are many other IoT platforms in the manufacturing world where things get connected with machines and you can actually in the end handle the complete end-to-end manufacturing process with the help of third-party developers that are outside of your existing firm network, that are just loosely connected with your platform, and they use their own creativity to innovate. Well, there's another element that's coming into play besides producers and the human crowd intelligence. Now we have artificial intelligence that is used for even producing content. We have news production. A lot of news nowadays are written by AI, not by actually creative writers anymore, or they're used to shape those people on the platform, through recommendations. There are terms like neural nets or natural language processing that you might have heard, and I will talk a little bit more about that. So that has been around before COVID, and it has been used more increasingly in response to the crisis. Here are just a few examples what platforms were really important. We had all the food delivery services, Instacart, DoorDash. Out of a sudden, you couldn't actually order food anymore because they were just so important. We have it in education, Zoom, Google Classroom, WebEx. All those platforms became important. Also in healthcare, out of a sudden, you did have a platform for antibody test or telemedicine. That's here a logo of Med here. Or in retail, Unacast, that offers social distancing metrics to predict also the risk for additional infection, or also predicting the visitor count in the store again, using mobile data that were available, put on the platform and then shared with also third-party developers. Siemens also opened their additive manufacturing network, a platform for 3D printing. Shown at here, just repeating myself, the Unicast as a social distancing scoreboard. They use mobile data and then developed the first offering to predict the social distancing in different states. And here an example of the 3D printing platform that Siemens has opened now also to third parties so that they can actually print locally, because you couldn't actually do all the shipping because of the constraints in our global value chain, manufacturing chain. That's another example I would like to point out. The City of Los Angeles and the Global Association for research methods and data science recently launched also a COVID-19 challenge to find ways to use AI to predict the COVID risk in their area, tapping into the crowd of scientists to build predictive models for LA and policymakers to decide what the risk in their city or in their state is. Well, so now we see that digital innovation has become more important, in particular digital platforms. And now the question is, how do we actually use digital innovation during the crisis, or as we move out of the crisis, to be successful? Let's just reflect on what matters during the crisis. For sure, we do need innovation. We need, new solutions, and a lot of them just to actually, respond to the crisis. We also need to reduce uncertainty. We need to be resource efficient because there is more, because of the crisis, the unexpected events that might occur. We don't know what's happening tomorrow. We basically act in the shadow of the future. And we also need to make sure that we have sustainability because we don't know what's going to happen in the future. At the same time, we need to be flexible and adapt to these, unexpected events, while also making sure that we're coherent with the past. So these are, these conditions that you're facing when you're innovating in the crisis. So I've actually addressed some of those questions in some prior research that might be help actually to understand how we can use digital innovation to innovate in a crisis. So one of the studies that I've performed that I'm going to talk about briefly is a paper that is also published in ISPIM that looks into platform architectures and the interplay between the strategies of all those producers on the platform. So there's app developers on Apple iOS, app developers for Facebook Game, the app developers of Salesforce enterprise apps, but you can also think of scientific platforms like our software development packages or other ones, even NanoHub. One important aspect that we know from the work on platforms is that if I'm a platform originator, platform owner, I want to make sure that I don't face uncertainty, that my platform is predicted evolving with high performance. Because I basically rely on all those innovation efforts of those thousands of people that built that app on my platform. And I cannot directly control that. I don't have the traditional ways of coordinating innovation that they used to have when I didn't have a platform. So one way of addressing that is that by addressing the platform architecture in a way, or the architecting in a way, so that it reduces uncertainty. There's work on ways of isolating the platform from uncertainty, and the way I do that is that I design the libraries, the subroutines, all those design elements in a certain way. That I reduce interdependencies and also try to, make the solution space a little bit smaller for the producer. Because in the end, when I develop an app, I have so many things to consider. What are the features that I need on the front end? What are the different technologies that I'm using? What design should I do? How do I deal with data updates? So it's a really complex problem. And digital innovation is also changing constantly, so it is a problem. And as I'm now facing the crisis, and there are so many uncertainty because of unexpected demands and so on. So one of addressing is that I build a modular architecture. There's the whole world of modularity in the platform literature. I basically try to reduce coupling, because if I have lots of interdependencies, one single change can ripple through and everything breaks, and all the effort I put into innovation are gone. So, and also I can put constraints. I don't allow them to use this because it would basically not work with the standard of the platform. That's been a dominant focus, and that's why many platforms try to build really modularity into their system. But there's one thing they often forget, that there are different producers and they use different strategies. So I'm considering here for two strategies, optimizing versus satisficing. Typically, platforms really try to build the optimizers, those that are competitive. They'll just really want to build the killer app. Think of Angry Birds, think of Pokemon Go, like the apps that everybody wants. But then there are also potential ways of thinking of satisficers. It goes back to some original work of Herbert Simon. Those app developers that don't necessarily want to be competitive, that focus on quality, craftsmanship, or more on the collective welfare. Well, this paper addresses that. Here's another screenshot. If I'm an optimizer, I'm actually trying to be on top of everybody in the rankings. We built an NK simulation model. It was together with two of my collaborators, and we actually find that at a certain stage of coupling, a certain stage of interdependency in the platform, satisficing platforms become better than optimizing. And here you see the distributions of that. So if I have optimizers and I have to optimize at a certain level of coupling, actually optimizing platforms create those inequalities. You have two peaks. There are a few apps that do really, really bad then. And that is because I have too much experimentation going on the platform, and then they fail and I create really inequalities. During a crisis, you don't want that. You want to have a sustainable platform. So it's very important of thinking of how to incentivize the developers in preventing those inequalities by nurturing satisfies in collective welfare rather than just focusing on looking for the winner takes all app or the Angry Birds. There's another paper that I've examined the interplay between flexibility and coherent in the search strategy. I'm not going to talk about that. That's published in Research Policy, where we find actually that app developers want to be flexible, but many platforms actually, and in particular this one, also only facilitate them and being coherent with the past. So there's this tension that they face, and the platform really needs to support that they can change that and be flexible. So think about, doctors on a telemedicine app that they actually think of new practices for now giving advice to doctors. So if that flexibility is not supported in the robot system, then it's not going to work. So I'm going to now talk about AI crowd partnership, because I think it might be some of you that be interested, and hopefully have time to finish that. And what I was trying to go into here is that we have artificial intelligence, we have crowd intelligence, but there actually have some commonalities. Crowds and artificial machines are both information processing systems, and they collect, store, and modify and interpret knowledge and resources that are widely distributed in the environment. To do that, they need to represent knowledge, and we do this by going back in our experience and everything we've experienced through our life, and then with predictions for reason. AI does the same in different ways. And with the advancement in the field, it's the data that are driving this. The field of AI, since the early meeting, the so-called Dartmouth meeting, 1958, when the term artificial intelligence was coined, has evolved from rule-based system, expert system, where everything was written in computer code, to machine learning intelligence, where the knowledge is, or the representation of knowledge is based on large volumes of data. We have there the deterministic intelligence based on label data. Some people that might know something about supervised learning, and then we have more unsupervised learning. We have deep neural networks that, in the end, mimic human behavior with neurons. And then we have generative adversarial networks. That's one of the advancements of machine learning. We have competing algorithms. Now we have natural language processing, semantic vector spaces, and reinforcement learning models. I could go into more details what these models are about, but in the end, we have advancement in these models, learn from large volumes of data, and allow us to make prediction and to reason. And some of them do really well. They do well to some extent in face recognition. They do well for forecasting, and they even do well in questions of science. So there's two papers that I'm just putting your screenshot on that found that actually non-supervised word embeddings algorithm has managed to extract knowledge from thousands of papers in material science and even predict based on old training data already a new scientific discovery. So AI is basically, in the end, to some extent, not substituting, but almost as smart as scientists. And there is also another study recently published by Brian Nuzzi and his colleagues that have found that an AI model is actually able to predict the replicability of studies comparable to best current methods, and it reduces the strain on research resources, so it reduces resource efficiency. So it's AI that can predict the reproducibility of scientific work. This is a really, really complex task. Well, why do we then get those news here? You know, when this is an MIT article that, oh, weird behaviors during the pandemic is messing with AI models. For example, we out of a sudden search for face masks, sanitizers, and disinfection, rather than searching for what's the best phone case that I need, one of the top searches in Amazon in the past. So there are now then flaws. You know, you had even wrong inventory prediction, upsetting content from the recommendations you get. So why is this? Well, without saying that, you know, I'm indeed the DEI expert, but when there are unexpected events, standard AI models that are used by companies become more fragile. Why is that? The strength of many AI models is that have this high processing capacity compared to the bounded rationale of humans, crowds. And they're very accurate in predicting under conditions of stability, where the training data versus the production data show relatively similarity patterns. They're also good at extracting like really deep level patterns of similarity based on volumes of text. But that become fragile if there's a nonlinear change in the environment. Out of a sudden, you know, we search for different things and where we need to be flexible. And when there's need for counterfactual reasoning, and this is a really strong human capacity that AI doesn't have. Even though there are new models like GANs and reinforcement learning or active learning, which are new AI models that try to build in some counterfactual thinking. What I'm arguing here is to use AI successfully during the crisis, where you have those unexpected events, where you need to have flexibility. You need to bring humans back into the loop. And this is also what active learning does. For example, it's a way of using certain sampling strategies to basically have humans enable or train, pre-train data for an AI. You need to division the labor between AI and humans for knowledge representation and prediction. And find ways to bring human back into the loop by basically, for example, refining their predictions or helping an AI, for example, to classify where human cannot. So bringing the counterfactual reasoning capacity. So that's one of additional suggestions that I would like to make here to the audience. I do have also one additional study, but I'm looking at my time. Actually, I think I'm running out of my time, because I'm actually also studying the digital transparency, not just to encourage reuse of innovation, where you can use those insights from machine intelligence and actually nudge people into certain behaviors on the platform, which is very important. I will not talk about that. What I just would like to do is just scrolling through. If you're interested, you can just explore also my website a little bit on this. I'm inviting also people that are interested in data science. Even if you're a beginner, we are going to launch a COVID hack using our own digital platform that we've developed with tools, with SDKs, where people that have used a notebook before, a Jupyter notebook, can help us to predict the social crowding risk and the economic risk for citizens in Indiana and other states of the United States. If you're interested in this kind of topic, you can go to WWIIScum. That's the website. And learn more about those COVID hacks that we're going to run and invite crowds of scientists and machine learning beginners or experts to contribute to that problem. That's it.
Thank you, Sabine.
I ran a little bit over and then I skipped the whole section, but I hope I gave you some inspiration. Yeah,
that was a great package, and then you're almost right on time. So we have time for questions. Yeah. So I will use my opportunity and make the first question, and then we have some questions from the audience, and I flagged a couple that I like to ask.
Yeah, so, let me now bring in the video, because I have basically shut off my video so that I'm not getting distracted. So. Mm-hmm.
All right. So my question is, and it relates to what you demonstrated related to the human crowds and then AI. So I had this question already in the beginning. So where do you see, which one is the bottleneck when we need rapid solutions to a crisis like this? Is the bottleneck typically the humans' organization, the ability of humans to organize solutions, or is the bottleneck in the technology?
So here's my response. Like, when you say technology, are you talking about AI, or are you talking about technologies in general?
You can choose.
Okay. In general is, when I talk about, since I finished, closed with the interplay between AI and humans, And the bottleneck is neither nor in humans and AI, because AI in the end is trained on data. And if I'm thinking of, making prediction of human behavior, they are trained on our behavior in the past. So then they use that to make predictions. So, and all of a sudden we have a change in behavior, in events coming up, and their reason from that. So in the end, it's on both sides, because we are not sufficiently adaptable and AI is also not. We have more counterfactual thinking ability. So what we need is a partnership, that we need to both kind of work together. The last, then let me talk about in general, like digital technologies or just platforms that also have typically some stability built into. And we often think of this stability versus flexibility being a paradox that cannot be resolved. But we actually found in some research that it can be. So you can be flexible and also coherent in the past. So and that is just the way the technology is built also. Can you basically build upon the things you've done in the past and at the same time being flexible? There are things that relate to social incentives, but it also relates to whether technology is actually upgradable or not. So yeah, it's a basic problem on both sides. Okay, thank you. Very, very thorough answer. I was expecting you to answer that it's both. So we have a few minutes and we have a few questions. Let's start with a very, very practical question. So Michelle Brocco is asking, what recommendations would you give for creating a new platform from scratch in terms of ramping up new interfaces? So if somebody wants to start a new one, what to do first? Okay, so a new platform, and right now don't know, what platform you kind of have in mind, but in general, if you build a platform, it is very important that you build it for generativity. When I say generativity, it relates to the fact that you cannot envision what the platform would look like. Generativity is defined as a system's capacity to change and adapt without any input of the originator. So you need to have some generativity. So for that, you need to have, I call them, design elements, you have tools for those that work on your platform and make them available. So when we're always gonna then balance this, you have too much change on the platform, you also wanna make sure there's sufficient stability. It's a double-edged sword, it's not that easy. So on the one hand, you don't want to make it, too modular, but at the same time, you need to also think about what is actually the crowd that I'm going to recruit. So that it's hand in hand, goes hand in hand. If you have if we're recruiting a crowd that's very competitive and very innovative, you need to give them very different tools to, you work with a crowd that is, not that educated, not that skilled, and also maybe not that aspirational on being innovative. So it depends on what is the crowd that I'm going to recruit, and then you actually design the tools in a certain way. Yeah, and I guess you need to work out ways how to actually recruit the crew, somehow resolve the chicken and egg problem in the. Yeah, that's another problem. So if you start, Well, let's not go there. It's gonna be a long story. There you can go. There's a whole literature on network effects. How do you build those, platforms? Yeah, you need a critical mass. That's also very hard. And I have my own practical experience, but I have not had a chance to show you Iron Hacks. I've been building a digital platform in 2016 for large-scale field experiments, where now thousands of people around the world have built apps for social challenges, finding a safe place to live, etc. And I know how hard it is to get people on a platform. Yeah. Okay, so I'm being mindful of time. We'll take the last question, a short one, and a short answer, and then we'll wrap up. Okay. So there's another question. Where is the collaboration part in this model? I guess it's referring to the platform models that you showed. So how do people collaborate and innovate in this kind of platform? Mm-hmm. So I didn't have time to go into that. You can actually build platforms that are competitive and some that are collaborative, and we have competitive and collaborative crowds on their own. But in the end, you have to always keep in mind that in any kind of platform, you do always have both things at the same time to some extent. Because even if I collaborate, I participate on the platform to win kind of some reward. Even in open source software, which is considered being very collaborative, you do have, reputational rewards. I want to be the best. So there's always kind of both at the same time. In some of the platforms, many contributions are teams that collaborate, and then you do have platforms that are focusing the principle of collective production of one single artifact. There you have true collaboration. But a platform, as the platform strives for diversity on one side, so you need to have kind of competing apps so that you address the diversity on the other side. So depending on what kind of platform we have, the platform as it's defined in literature typically thinks of diversity. The collaboration happens at the team level to some extent, but you also have competition. So you have collaboration and competition actually at the same time, and they typically go hand in hand.
Okay, thank you. So I learned a lot. It was a great presentation. I wish, as always, there was more time.
Yes, I wish also I had a bit more time.
Exactly. Okay, so thank you everybody who was online, and I hope to see everybody tomorrow also at ISPIM. And Sabine, thanks once more, and have a great afternoon and evening.
Mm-hmm. Thank you.